Space may seem empty, but it's actually filled with giant clouds of gas and dust. These clouds, called nebulae, are the birthplaces of stars. Imagine a giant cosmic cloud, 1,000,000 times bigger than our solar system. Inside these nebulae, gravity pulls everything together. Gas and dust clump together, getting denser and hotter over millions of years. This process is like a snowball effect. Eventually, the core of this clump becomes so dense and hot that nuclear fusion begins. Hydrogen atoms fuse together to form helium, releasing enormous amounts of energy. A star is born. Once a star ignites, it enters a long, stable period called the main sequence. Our sun is currently in this phase, which lasts for billions of years. During this phase, stars fuse hydrogen into helium in their cores. The size and temperature of a star determine its color and brightness. Hotter stars appear blue-white, while cooler stars appear red. Our sun is a yellow dwarf star. Imagine a campfire. A large log burns longer than a small twig. Similarly, massive stars burn brighter but have shorter lifespans than smaller stars. The life cycle of a star is determined by its mass. Stars like our sun, with relatively low mass, will follow a different path than massive stars. Think of it like two cars on different roads. One car travels a long, scenic route, while the other takes a faster, more intense highway. Low-mass stars will eventually become red giants. Massive stars, on the other hand, will evolve into supergiants. Both paths lead to spectacular ends. As a sun-like star runs out of hydrogen fuel in its core, it starts to cool and expand. It swells up to an enormous size, becoming a red giant. Imagine a balloon being inflated. This is similar to what happens to a star as it transitions into a red giant. The outer layers expand outwards, becoming cooler and redder. Red giants are truly gigantic. If our sun were to become a red giant, it would engulf Mercury, Venus, and even Earth. Section 5. Supergiants living large and dying young. Massive stars evolve much faster than their smaller counterparts. They burn through their hydrogen fuel quickly and then start fusing heavier elements in their cores. Think of a high-performance sports car. It consumes fuel at a faster rate than a regular car. Similarly, massive stars burn through their nuclear fuel much faster. This process causes the star to expand even more than a red giant, becoming a supergiant. Supergiants are the largest and most luminous stars in the universe. Section 6. Supernovae, the grand finale. The core of a supergiant is like a cosmic pressure cooker. It fuses heavier and heavier elements until it eventually forms iron. Iron fusion does not release energy, so the core collapses under its own gravity. Imagine a building imploding in on itself. This is similar to the core collapse of a massive star during a supernova. This collapse triggers a shock wave that rips the star apart in a titanic explosion called a supernova. Supernovae are some of the most energetic events in the universe. Section 7. Stellar remnants, white dwarfs, neutron stars, and black holes. After a supernova, the core of the star is left behind. Depending on the mass of the core, it can become one of three things: a white dwarf, a neutron star, or a black hole. Think of these stellar remnants as different types of cosmic fossils. They are the remnants of dead stars, each with its unique properties. White dwarfs are the remnants of sun-like stars. Neutron stars are incredibly dense objects composed mostly of neutrons. Black holes are regions of space-time where gravity is so strong that nothing, not even light, can escape. Section 8. The cosmic dance, the importance of stars. Stars are not just beautiful objects in the night sky, they play a crucial role in the evolution of the universe. Stars are the factories that produce heavy elements, the building blocks of planets and life. Think of stars as cosmic alchemists, transforming lighter elements into heavier ones through nuclear fusion. These elements are then scattered throughout the universe by supernova explosions. The iron in our blood, the calcium in our bones, the oxygen we breathe, all these elements were forged in the cores of stars billions of years ago. We are literally made of star stuff. Section 9. Conclusion. Our place among the stars. The life cycle of stars is a tale of birth, life, and death on a cosmic scale. From the stellar nurseries where they are born to the supernovae that mark their demise, stars shape the universe as we know it. Next time you look up at the night sky, remember that you are witnessing the cosmic dance of stars, a dance that has been going on for billions of years and will continue for billions more. We are all connected to this cosmic dance as we are all made from the remnants of long-dead stars.